we are going to look at a hydroboration oxidation of a terminal alkyne, and we're going to end up with an aldehyde. Now to do this, we can use an array of bulky boranes, and we've got 3 here. We're going to end up using disamyl borane for this reaction, but as you can see, the other 2 will work just fine as they have the 1 hydrogen to do the 1 reaction. This is going to be a syn addition, as both the hydrogen and the borane are actually going to be intermediary and attached to the pi bond simultaneously. As this is occurring, the bond between the hydrogen and the borane are going to break, and the hydrogen is going to form a bond, and so is the borane. Now, what's interesting about this is that you don't end up with borane in the next step. Because it's in a basic solution, you're going to have an OH come in there and kick off the borane. And so you're going to end up with an enol. Now, the enol is an alkene and an alcohol put together. And as you can see, we still have the hydrogen, but we're going to do a deprotonization, and we're going to steal that hydrogen from the alcohol. Now those electrons are going to go back to the oxygen, and they're going to have to stabilize somehow. And so we're going to end up with 2 products, and so we're going to get a major and a minor, and that oxygen really wants that double bond. And so in this, you have the possibility of rearrangement. And so tautomerization is what's happening. This is what most books will show you, as we're going to protonate second. And instead of that double bond moving over and creating our minor product, that double bond is actually going to steal the hydrogen off from the water. And in this, you're going to kick off the oxygen and end up with an aldehyde. Now, this is our actual observed product. And this reaction is reversible. Some things we know: this is a syn addition. Use of bulky boranes gives better yield. This is an anti-Markovnikov reaction, and enol means alkene and alcohol.